This is the third and the last video in this series for the lessons for 6D, and in this one we're going to be talking about using circles and inscribed triangles. If we remember from the first vocabulary video, whenever we have a triangle that's inscribed in a semicircle, we can assume that the angle that is the inscribed angle is got to be 90 degrees. So that's what I'm going to start by doing after we read through this problem here, is putting those labels in. We're told first of all that triangles ABD and ADE are inscribed in circle F, where AB is congruent to BD. Now, just so you know, there needs to be arc measures there. That's arc AB and arc BD. So I can go ahead and mark that on the diagram. Those are the same. And what I want to do is I want to find the measure of each numbered angle. If the measure of angle 1 is given to us as an algebraic piece of 12x minus 8, and then the measure of angle 2 is 3x plus 8. So let's put on our right angle symbols. We know that angle E and angle B are going to have to be 90 degrees, both of them. Then I think you can see that since those arcs are the same, that means that the angles themselves are going to be the same. Angle 3 has to be congruent to angle 4. And if it's in a right triangle, then all that leaves is for 3 and 4 to both be 45 degrees. So we got a 45, 45, 90 triangle there. Clearly though, triangle ADE is not going to have a 45, 45, 90 relationship. However, we can find it, finding angle 1 and angle 2 that is, by going through a simple calculation that the angle algebraic pieces, 12x minus 8 plus 3x plus 8, has to equal 90. Adding like terms, we get x is 6. So that's going to help us to figure out the measure of angle 1 and 2. So we're just simply going to substitute in 12 times this x value that we just found of 6 minus 8 gives me 72 minus 8, or 64 degrees. And then the measure of angle 2 there is 3 times the x that we found as 6 plus 8 is really 18 plus 8, or 26 degrees. And just as a final check, we want to make sure that angle 1 and 2 here are going to add back up to 90, which they do. And of course 3 and 4 are going to add up to 90 because we cut the remaining 90 degrees in half to figure out what those values were. So that's our first example, using semicircles having inscribed triangles in them. Next example that's like it, not in your book again, is triangles TVU and TSU. This time are inscribed in circle P with arc VU congruent to SU. So let's put those markings on as we pause here to read through the problem. And then if that is true, then you guys, we know that angle 1 has to also be congruent to angle 2 because they're inscribed off of congruent arcs. And by extension, if those two angles are the same, and we already know that angle V and angle S is 90 degrees, we can say that angle 3 also has to be congruent to angle 4. So really all we're looking at is two separate angle measures in this picture. So what we need to do is use the idea that angle 2 and angle 4 in the next example, or the next sentence here, are going to add up to 90 degrees. 2 and 4 in that right-hand triangle are going to add up to 90 degrees. So that's the algebraic piece x plus 9 plus 2x plus 6 that has to equal 90. Adding like terms, subtracting the 15, and solving. We get that x is 25. So angle 2 is just going to be 25, or x, plus 9, so we get 34. And remember we said angle 1 and 2 were the same, so there we go there. And then angle 4, if we substitute in our x value that we found as 25, we're going to get 2 times 25, which is 50, plus 6, so we get 56. and we know angle 3 has to be the same. And that's the end of that problem. As we go on to our examples, we're going to be working not with inscribed triangles anymore, but in example 5 we have an inscribed quadrilateral. So just a reminder of what that vocabulary word means. That means we have a four-sided polygon that is inscribed, meaning all of its corners lie on the circle. So the diagram that we have there says circle P has quadrilateral ABCD inscribed in it, something like this. And we have A, B, C, D. And notice as we name that polygon, we kind of go in a clockwise motion as we start and go around to each corner, okay? It's inscribed in circle P, and we're told a few of the angle measures. We're told that the measure of angle B is 80 degrees. And again, you can see this diagram is, the way that I've drawn it anyway, is not drawn to scale, so keep that in mind. Go with the angle measures themselves, the number's not what it looks like. And then we're also told the measure of angle C is 40. What we want to do is we want to find the measure of angle A and the measure of angle D. So in order to do this problem, we need to remember Theorem 10.8, which actually was not in our vocabulary video, so let's talk about that now. It says that if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. Remember, that means they add up to 180. So I'm going to start over here by saying that supplementary relationship, angle B plus angle D, has to equal 180. And also at the same time, angle A plus angle C has to equal 180. So B I know, I can put in 80 there, plus angle D equals 180. That means that the measure of angle D using subtraction has to be 100 degrees. I know angle C, so I can put that in. Angle A plus 40 has to equal 180. So the measure of angle A, when I do a subtraction, is going to give me 140 degrees. And it's just that simple. Think of those opposite angles being supplementary. Opposite angles, supplementary. Pretty simple. The next example, we're going to sketch a diagram. This time QRST is inscribed in circle M. So here is circle M. And QRST, and I'm going to label it, I think, like this. Your diagram can look any way you want so long as you go with the measures that are given. Again, a reminder, not drawn to scale, okay? So in this case, we know that the measure of angle Q is 87 degrees, and the measure of angle R is 102 degrees. And what we want to find is the measure of angle S and the measure of angle T. So using our supplementary relationship there, we'd take Q and the angle opposite it, which would be S, that would add up to 180 degrees. And we would also take angle R and the angle opposite it, which is T, and that has to add up to 180 degrees. Again, simple subtraction. We know Q, we need S. Subtract an angle S has to be 93 degrees. Measure of angle S, that is 93 degrees. And plug in what we know here. R is 102. Angle T is our unknown. but not for long. We subtract, and the measure of angle T has to equal 78 degrees. That's it for an inscribed quadrilateral, you guys. So at this point, make sure that you turn over to your on your own yellow page there in your packet and complete those 3 examples for class next time. See you later.